Hi. I'd like first to thank Andrea and all the organizers for inviting me here today. I'm involved in this industry since 2012, and most of my time is spent in running Bitvault, which is a cash-to-Bitcoin exchange, and Oraclize, which is the thing we are focusing on now. So, as the title says, Oraclize is a service, an Oracle service which is provably honest. So, does any of you have an idea of what an Oracle might be? Can you raise your hands? Okay, good, more than all. Good. So, let's try to start from scratch to see what is the goal, what is what we want to reach here. And we are talking about triggering transactions as soon as an event is verified. So we can have two categories, let's say, of events, and one is on-chain events and the other one is off-chain events. So when we say on-chain events, it means that the event is verifiable by the blockchain itself. So if we talk about Bitcoin, an example of an on-chain event can be a new block, for example. So in Bitcoin, this is native, so you don't need to use any external provider to verify this data. So with Bitcoin, we have the so-called unlock time, which is a property of the transaction, which is optional. And by default, it's 0. It means this transaction is valid now. But you can set a timestamp in the future or a given block in the future so that a given transaction is not valid until the given block or timestamp or timestamp is reached. So this is an example of on-chain event. So oracles play their role when you have an off-chain event. So an event which is not verifiable on-chain. So this is an example. Let's say that we want to move some funds from A to B just when a condition like this one is verified. So when the BitTime price goes below a certain value. So in this case, of course, you cannot have the blockchain itself to verify itself because it cannot understand what BitTime is. And you cannot really open a socket to the BitTime server in a decentralized way. Yep.
Would you be so kind to define Bitstamp?
Bitstamp is one of the leading exchanges, Bitcoin exchange in the world. Essentially, it's based in Slovenia. Maybe now it's moved
London.
to US. I'm not sure.
It's London now.
It's London.
Yeah.
Okay. Yeah, I think the team is based in Slovenia, but they are based. Yeah, they are based in London. So yeah, Bitstamp is just the exchange. Instead of this condition, you can think about any other condition, such as the temperature in Zurich now. Okay. In this case, if you want a transaction to happen just when a condition like this is verified, you cannot execute this on-chain, and you need the intervention of an external party. So the point is, how can we enforce such a logic? And with enforcing, I mean having this transaction to take place really just when the event is verified, not in all the other cases. How can we enforce such a logic without adding any trust line? Because all the point of blockchain and all the complexity and the inefficiency of the blockchain comes from having a trustless system. So even the first paragraph in the Satoshi paper in 2009 mentioned as one of the first reasons to build a system like this, the one of removing middlemen. So what's the point of removing trust lines, which in theory can be the weak point of the system? Well, it's much more complex than what you can expect to have this whole system work without adding trust lines. So we will see that later. And we can see two different approaches. So the first one is the solution of this issue in Bitcoin or any other cryptocurrency similar to Bitcoin. And the other approach is the one of Ethereum. So Ethereum has the concept of smart contract, which is very different from the Bitcoin sense of smart contracts. We'll see that later. So the Bitcoin approach is to have an escrow, which is a trusted party, which is taking care of verifying the condition. So you're trusting this external party to provide the right data and to sign the transaction just when this transaction is verified. While with Ethereum, in theory, you can have the smart contract to take care of it. We'll see more about that later.
Just quick. Sorry.
Yeah.
Why escrow? Exclamation point. What are you trying to imply?
The point is that the party providing an external data, an off-chain data, is mostly referred to as Oracle.
Yes.
And so what I wanted to underline here was, so in the Bitcoin sense, is an Oracle just an escrow or not? Because in Ethereum it doesn't.
What is an escrow?
An escrow is just a third party which is confirming a transaction, okay, as soon as the two parties involved are, as the conditions that the two parties involved decide are verified, right? So in this sense, you might say that an Oracle is exactly an escrow, right? Because the Oracle is doing exactly that. So it's verifying that a fact happened, right? So I mentioned Oraclize here. Oraclize was a first attempt to implement something like this. So in the Bitcoin sense, you have two parties. Let's say Alice and Bob. So these were wallet A and wallet B that we had before. That want a transaction. Sorry. That want a transaction to take place just when an event like the one we mentioned before is verified. So the way to do that in Bitcoin is to delegate the event verification to an oracle, to a third party. The way to do that is by leveraging multi-sig addresses. So a multi-sig address is essentially just a way in Bitcoin to say that some funds can move just when a given number of signatures are applied to a transaction. Okay. So usually you refer to multi-sig wallets with n of m, which means that you have n keys, and a minimum, at least n keys, needs to be applied to a transaction for the transaction to be valid. So, thank you. So a minimum of n transactions need to be applied. So in this case, it's very interesting because you can have, for example, a multi-sig address with, let's say, m, which is 10. So let's say 10 signatures total, and you can have different parties, each one of these, which is in possession of one of these keys. And you can say that all of these parties need to verify your condition, the fact, and to put the signature once the event for them is verified. Okay. So this is interesting because you can set, in the way the wallet is built, in the multi-sig logic, the minimum number of signatures that you need in order for the event to be considered valid. So you can say to 10 different parties, please check what the temperature in Zurich is, and when it goes below 5 degrees, please put your signature. So in this case, you didn't even mention where to get the temperature from. You just told to these third parties, to these single independent parties, which in theory could even be humans. It doesn't need to be something automated. You are telling to all these parties to put their signature, their single signature to the transaction when the event is verified for them. You are not even asking for an evidence of this. And with this n of m thing, you are saying when 6 of 10 of you agree on the result, so on the transaction signing, for me it's enough, and it means that the transaction can be valid because I think that having 60% agree on the given fact is enough for considering the fact to be actually verified. So this is weak in some senses, in different senses, because the given parties, the given signing parties, could be cooperating against you, for example, and could be signing a transaction even if the event is not verified. So in the Bitcoin sense, you really have the majority, which is choosing for you if the transaction is valid or not. And this is what Oraclize was trying to do with Bitcoin. So Oraclize was just an inter-oracle communication protocol, so that you could, in practice, do something like this. So have all the oracles have a standardized way to communicate with each other and to submit to them the given event. So the event is sent off-chain. On the blockchain, you are not storing anything about the event. You are sending to the Oraclize network the event and the transaction you want to be accepted, right? To be signed by the parties. So with Ethereum, we have the concept of smart contracts, which is very interesting in the Oracle sense, because the big changing thing here is that you can have the logic to be enforced on-chain. So this means that you are not asking to an external party. It doesn't make sense to ask to an external party to verify an event. You can just ask to a third party to provide to you the data. Then you can have your smart contract to choose which logic he wants to apply to this data in order to have a transaction to be approved. So this means that you are removing some trust to the external party, because you can put all your logic on chain, and this is interesting even because with Solidity you are actually programming, you are coding the logic, and which means that you can have any logic. While if with the approach that we discussed before with Bitcoin, the actual logic was much weaker, because the logic, there was the need to communicate this logic to the external party, which means that you need to formalize this way and to find a standard way to communicate this logic to all the oracles. So in the example before of the price, this was trivial, because you were just comparing the price. Okay, so you were just saying if the price goes below a certain value, then. So this is very easy, and you can just say to all the oracles, please note that in my condition I will put a generic query, then a comparison sign, symbol or something, and then a number. But this can be arbitrarily more complex, so it can be much more complex. And by moving the logic on chain, you are delegating all this complexity to your code. So you can have really very, very complex logic, and you don't need all the parties to understand your logic, because they don't care and they don't know anything about your logic. So let's talk more in depth about oracles and what they actually are, because I think that due to people referring to oracles in very different ways in the last few years, there is a lot of confusion, and people really mean different things when talking about oracles. So at the beginning I asked how many of you already know what an oracle is, and more than half of you raised their hands. So I would be curious to understand what an oracle is for you, but from the feedback I received so far, I've seen that any of these can be an oracle essentially. So ranging from humans, like Vitalik. So if I ask something to Vitalik, I can say that his answer for me is correct, and in my opinion he's an oracle, because he was the one saying something that triggered a transaction, for example, in some ways, or a prediction market for many. It's like Ogre or Gnosis, Group Gnosis, is often referred to as an oracle. Or Bloomberg, because it's providing reliable financial data, in theory. or Bitstamp because it has public APIs, or something which is much harder to measure, like the sentiment of Reddit Bitcoin, or Wolfram Alpha because it can answer any query pretty much, or Reality Keys, which is saying it's an oracle, and in some sense it does. So all these are oracles in different senses. Okay. So this is the definition that I usually use because I think it's quite clear, easy to understand, and with better naming we can do some discussions which are more interesting and more precise. So essentially, for me, a prediction market, Bloomberg, the Bitcoin blockchain while talking about Ethereum, or the Litecoin blockchain while talking about Bitcoin, or Wolfram Alpha, or any other data source is a data source. So a data source is a self-explanatory. So it's the party which is providing the data. So it doesn't know anything about the blockchain, it's blockchain agnostic, it doesn't need to know anything about the blockchain, it just provides the data. Then we have the query, or the formula, if you want, which is something which defines the data that you are looking for from the data source in a very specific way. So when I say, please tell me what's the temperature in Zurich, the result can be very different depending on where this information is fetched from, for example. So I won't find the same exact value from all the data sources that I could use. So the query, the formula, needs to be as specific as possible and needs to be in a form that can be understood by the data source itself. So in the case the data source is Vitalik, I could write something which is human readable because there is no need to formalize the query in a way that a computer can understand. While when I write a formula for Wolfram Alpha, I need to ensure that Wolfram Alpha is able to understand what I'm saying to him. While when I'm talking to Bitstamp, for example, I need to make sure that the query is something that Bitstamp can understand, like the API that Bitstamp is providing. So there are really different types of formulas and queries that depends on the data source itself, are very specific to the data source and can vary a lot. You see that I didn't specify anything about conditions, comparing data, things like that. And why is that? The point is that the formula or the query can contain a condition or not. So for example, I could ask to Bitstamp in my query what the price is of Bitcoin in US dollars, for example. Or I could ask to Wolfram Alpha what is the price of Bitcoin in dollars without specifying from which exchange he needs to get the data from. So he will take it from whichever data source it wants. Okay. Or I could even use as formula for Wolfram Alpha a condition, like please tell me if the price is above a certain value or not. So in this case I will get back as a result true or false, while in the case before I will get back a number, right? And then we have the oracle. The oracle to me is just the part which is connecting the data source to the blockchain. So essentially, the oracle is defining the communication protocol between the data source and the blockchain. This is not trivial, because even Oraclize, as we were saying before, can be considered an oracle in this sense, because Oraclize was exactly defining the protocol, the communication protocol with the data sources. So here we have the oracle, which is the party you want to talk to fetch a data from a data source. by asking to him the right formula. So here is where Oraclize comes in. At first, the project was started in February last year, and it had nothing to do with Ethereum. It was told just to be part of the Horizon network at first. So our idea was to be one of the oracles, one of the data sources with this naming, which was part of the Horizon network. The point was that there were no oracles, there were no other data sources waiting to join the network, so we were the only one. And the Horizon network wasn't even maintained. So I got in touch with the developers of Horizon and asked them what was the very reason why they left the project. And what they told me was, look, we noticed that even though this is very interesting from an academic point of view, we see that there is no interest yet, at least on Bitcoin. It's too early. Nobody is focusing on this. And in order to have a Bitcoin-based, secure oracle structure, as we said before, you need to have really many oracles. Because you need a lot of oracles to avoid them to collaborate and to give you back a wrong result, to be corrupted. So for example, if I have just an oracle network with two parties, it's very easy for them to collaborate and to approve any transaction, or just a transaction that they are paid by somebody else to approve. So it doesn't make any sense. So the point is that with this scenario, you really need, I'd say, at least 10, 20 oracles for this thing to work. And another thing is that these oracles didn't have any guarantee as for the uptime, for example. So even if I have 10 people, 10 bots, or things like that, that are part of this oracle network, how do I know that these 10 oracles are really online when the fact is verified? How do I know that 10 are signed up, but just 3 in practice are part of the network? So it's very complex. So maybe they are accepting my query, but then they are not executing it. So there are a lot of complex key points here that make the whole thing weak unless you have a really good number of participants in the system. So I tried to find another way out, because I really thought at the time, and even today, that having data to blockchain applications is something really important to have useful applications. And at the time, it was April or May, I discovered this project which was called TLS Notary. And this TLS Notary was a very complex protocol, which was essentially a modification of TLS. And the whole point was that they were building this stuff to notarize web pages. So for them, this was a way to fill in the gap in the decentralized exchange experiments. So you know that one of the main interesting topics in the last few years have been how do we decentralize the cryptocurrency exchanges. And the point is that when you handle fiat money, it's very difficult. How do we prove that one party did actually pay, and things like that. So the TLS Notary guys tried exactly to fill in the gap of this issue by saying, look, we provide a tool by which you can notarize a web page that you have on your own machine and prove to a third party that you really received a given web page at a given time from that specific server. How does this help the process of exchanges, of decentralized exchanges? It's very important because once, for example, you submit the request for a wire transfer, you get a confirmation back from the bank. How do you prove that to a third party? So the trivial way, the way you do that today is you just get a PDF and you send the PDF back to the other party. So there is no need to say that this is very easy to fake, and that is much less useful than an actually notarization of the page. When I say notarize a page, I mean that you have a cryptographic proof showing that this page was really that one. It wasn't altered by anybody. Okay. So obviously there are many other major weak points in the process, because the wire transfer can be reversed. You can easily cancel it before it's actually sent, even if you get the confirmation back from the bank, and other issues like this. Anyway, this was very interesting from an academic point of view. As a protocol, it was very complex, but it did solve this issue. And the only trust line involved in this whole process was for its inner workings. I won't go in deep into that unless somebody of you ask a specific question on this, because it's very complex. But the only trust line involved was with Amazon Web Service. So essentially, you were moving the trust away from an untrusted third party, which was any user, which you don't know, to Amazon Web Service, which of course is a centralized party and could potentially alter the data coming from their APIs, for example. But it's much easier to trust a party like Amazon than any other party. And most of the services that we are using every day is built on the top of Amazon Web Service anyway. Still, it's a trust line involved. Anyway, at this point, I was thinking about how to solve this issue with the Oracle system and with Oraclize, and I thought, what if we use this same technology to provide to a third party that not that my wire transfer was sent, but that the data that he is asking me for was actually not tampered by me. So in this case, you have a complete change in the discussions that we have seen so far, because you don't really need anymore an Oracle network to ensure that the data is valid. So the point before was, let's ask to as many parties as possible, so when they agree, I consider the data to be valid. Here you're saying, I can be 100% sure, if I trust Amazon, that this data is really correct. But by having just one party, you are not solving, even with TLS Notary, all the issues that you can potentially have with an external party, which is, for example, the uptime. Because you can understand that it's easy to say that an Oracle network with 1,000 participants will always have some participants online. But with a centralized party, who is guaranteeing that the service will be online? And the other thing is, what if, for law enforcement reasons, the service doesn't want to give me back the result? So this is not censorship resistant. Okay? Still, it's a good compromise, because you are sure that the data was correct, you're 100% sure, and you can give an evidence which can be stored in a decentralized network, for example. So, essentially, what are the trust lines involved here, again? So we have Amazon, and we have the data source. The data source is the only party which will always have your trust, because with the naming that we defined before, we are always defining a data source which is specific, so you choose the data source. If for you the data source is Vitalik, and Vitalik does lie, then the data, even if it's coming from an Oracle, and from the Oracle perspective it's correct, in practice it could be wrong. So you always have the trust line with the data source, and the only way to lower this trust, it will never be zero, but the only thing that we can do when you're asking for some data is to ask for the same data to different parties. So again, this is something that in the Ethereum perspective, for example, you can completely choose in your code. So the Oracle doesn't really know anything about all these logics, and you can have your code which is saying to the Oracle, please give me this data from this data source and this same data from this other one. The Oracle will just see the single requests that you make to him, but will not understand what is your logic, and it doesn't need to know. It's just providing you the data. So, what is the compromise here? Is to say, can we have something today which have a good security, not perfect, but can come before the Oracle network that we will hopefully have in some years? I'm not confident in saying months, because it's since 2013 that I keep listening people saying that it's coming in months. So it's not coming in months. People have no interest in starting an Oracle system, because it's very hard to understand how to monetize it, and it's very hard to find a consensus between oracles, because if you have oracles speaking different languages, this is useless. Okay. So with Oraclize, we have to design our own way to talk, and in theory you could have other oracles which adapt to our language. But in practice, today we are the only one offering a service like this with this language. Still, as I said, there is little trust involved, or a lot of trust involved, as you want to see. It's Amazon, and it's not censorship resistant. As for uptime, it's not really a big problem, because people keep saying that blockchain does solve the uptime issue. But the issue, I mean, how many of you have ever seen Google or Amazon offline per more than a few seconds or minutes in the last few years? I mean, the uptime issue was really solved by years, by big corporations. So I don't think that blockchain does really solve the uptime issue. And even with a service like this, we have all the interest in keeping the uptime as high as possible, because it will impact our reputation. So the reputation in this case is not about providing legit data, correct data, because we are providing a proof of doing that. So you are not putting trust in us for this. You are just putting the trust in us that we will give you back an answer. But there are two cases in which this will not happen, which is our system is down, which we have to do everything possible for this never to happen, and we cannot give you back the response because your contract is illegal, for example, and the police forced us not to give you back the response. So obviously this is not up to us. But if the police comes to us and tell us, you cannot really, for example, I was hearing before the speech that some of you were talking about legality of DAOs and things like that. So let's say that we have a contract which is potentially illegal, and let's say that it's not possible to understand who the owner, the legal owner is, because, for example, there is no owner, and the people designing it is anonymous and just put the source out there on GitHub somewhere, and somebody who is not known deployed that. And let's say that people start using it. What do you think that the police will do once there will start to be some complaints, or once they notice that this thing is not legal and they have to stop it? So the most obvious thing will be, in the case this contract relies on an Oracle system, to tell the Oracle not to give him back an answer, so that the contract, the DAO, will stop working. And this is the case for a single Oracle, like Oraclize, but even for an Oracle network. Anyway, with a single Oracle, you understand that it's much easier for law enforcement. So, for example, I don't know how many of you know Join Market. Join Market is an interesting example, because Join Market is an open source code which lets you be part of a network, and the only thing that this network wants to do is to facilitate the mixing of bitcoins. So this is an activity that in most countries is illegal. And being part of this network, in theory, is illegal because you are facilitating an illegal operation. Still, it's very hard for the police, for example, to force all these nodes to stop their operation. And they didn't even try yet, because this is very new, and there is no real interest in doing so. But what do you think will happen in the case a terroristic attack or something like this is proven to use something like this? I don't think it will happen, I don't know. But I can assure you that today, in Brussels, they are talking a lot about Bitcoin and anti-terrorism, because it was proven, and I know that some sources say that it's not true, but I can give you more details later. But there is a proof coming from France that it was actually used in for some things linked to the terroristic attacks. Okay. So this was not the only tool, and this was just used for some side things, but still, this is enough for the European Union, the Parliament, to start doing something. Okay? So obviously, if the thing is too small, there is no interest in attacking it. But if this thing bothers somebody with something very strong, which can cause big issues, like terroristic attack, then I easily see the police starting to say that joint market is illegal, and that it's illegal to run one of these nodes, and they can start to get after these nodes. So even with a network like this, it's harder, but it's still possible. So even with a Bitcoin network, but obviously, it wouldn't be easy to go after 8,000 nodes. Okay? Any questions?
What if Oraclize were to hide behind Tor and I2P? Nobody could figure out where they were located geographically.
Correct. And this is what nodes, even in Bitcoin, today do in some cases, and what joint market can do. And even if you think about Open Bazaar, this is even a more interesting question. For Oraclize, it doesn't make any sense, because the ownership is public. Everybody knows that I'm the founder. So even if I use a service to anonymize the server, anyway, the company is incorporated. You know, there is a real company, legal company behind it.
So in theory, if somebody makes an anonymous Oraclize, we can use it, right? Because
yes, if you trust.
It's honest. So
correct. If you trust the anonymizing tools that we have today, about 100% anonymity, which I don't think any tool is proven to be so. For sure, Tor did prove the other way. So, yeah. You still have the issues of uptime, which obviously the service has all the interest for its reputation to solve on its own, but it's not granted. Like, not even for us. Well, actually, in theory, for a service which is not anonymous, like ours, you have, to some extent, maybe, a stronger guarantee of uptime, because if the service is down, and this does cause you some damages, you could sue us, right? In court. While with an anonymous one, you wouldn't be able to do so. Yeah. So, okay, so this was a screenshot about our Bitcoin integration. The quality is not good enough to read everything, But this was just to show what I said before, so that with the Bitcoin integration, this is our web page, and you can create a partially signed transaction and submit it to Oraclize, and specify the conditions, the full event. So what is the data source? Wolfram Alpha, the formula, temperature in Venice, and the conditions equals, less than 8. And it can be even more complex. And when the temperature in Venice is less than 8 and the Amazon stock value for Wolfram Alpha is greater than 370. So this is verified by Oraclize with a TLS notary proof, and we provide the evidence of this data to be correct. But still, this cannot be enforced. So this is the way with Ethereum it works with Ethereum. So you have the logic inside Ethereum, and you just ask for Oraclize for the data from a given data source, and we will give back to you, to your smart contract, the answer and the proof, honesty proof.
Quick question. How do you deal with what I would call an honest mistake? Because you don't control the database, like the temperature. Maybe somehow there's a mismeasurement and later they correct it because it's not unalterable. By the time it's corrected, maybe the payment is already made.
You mean if the data source does provide the data wrong?
Yes, but then they realize and then maybe they just fix the data source, they correct it.
Yeah, but this is one error coming from the data source, and as I said before, the trust line with the data source is always there. So it's up to you and to your logic to go around this by asking, for example, to different data sources and looking for an average, or things like that. So Oraclize does focus with the Ethereum integration to providing data. Then it's up to you to understand how to use this data.
So
And how to make this data more meaningful.
when you say it's proof that it's correct, it's just proof that
Our
the
honesty.
percent is really what is in the
It
database.
proves just our honesty, yes. So that we didn't tamper, we didn't alter the data.
There's always a risk if you think about a soccer game that ends 3-0, but afterwards one team
Yes, correct.
loses forfeit and they have to change it, then it's
Yeah,
already more contract is executed anyways. Probably can't change it.
So, yeah, this is an example code of the logic on Solidity. Essentially, it's very easy. We provide on-chain APIs for Ethereum. So you include our helpers, API helpers on the top. You just extend with using Oraclize our contract. And in your contract, you just say to Oraclize that with set proof that you want the TLS notary proof distributed over IPFS. And then there is our communication protocol, which is this one, for example. So give me back the result in 60 seconds, not now. The data source is a URL, so any URL. This is my URL, and this is one public API of Kraken. And please don't send me back the raw data, because I would have an hard time to get the right part into the contract. But give me just back a part of it. This is in JSON, and give me back this exact field. And once Oraclize will get this information back asynchronously, it will call your callback function with the ID of the query, which is returned here. It's not saved. It's returned. The result as string, always a string, and the proof, some bytes which can contain an identifier of the proof, depending on the proof time that you asked for. Because in theory, we could even support different proof types. With set proof, you can set other type of proofs. So for example, now we are working on an Intel SGX based one, which is way different. But in this case, you would have the trust line not on Amazon, but on Intel. So you understand that in this case, you could ask Oraclize to provide both proofs. And if something, for this to give you back a wrong result, you will need both Intel and Amazon to cooperate to give you back a wrong result, which is pretty unlikely, I'd say. Okay. So this is our off-chain honesty monitoring. So if you go to our website, there is this client-side web-based tool. You can even save it and use it offline. You don't need our service to be up. This just connects to an Ethereum node, to your local one if it's running. If it's not running, it connects to a read-only public node that we set up. And it connects in the same way to your local or remote IPFS node. and it has an instance client-side in JavaScript of TLS Notary. So what it does is it looks for the last 12 hours of blocks when you load the page of Ethereum. It looks in each block for our transactions, so the transaction coming from Oraclize that gave back the result, and it looks for transactions with the proof, because the proof is optional. If somebody doesn't want the proof, up to them. So in the last 12 hours here in the screenshot, you see that all the transactions add the proof, because the green one are the one with proof, and each one of these square is actually a transaction. So it does load all the transaction. It looks in the transaction for the hash of the proof. It does fetch each single hash, each single proof via IPFS. And once this is downloaded on the client side, so it's very heavy, it does verify with TLS Notary if something is wrong, or if it's valid. In the case it's valid, it means that in the last 12 hours the Oracle has been honest. But you can even, in theory, look back to a few months ago. Just a matter of configuration. Doesn't make any difference. So in this case, you can look offline for the Oracle honesty, and if the Oracle honesty is compromised, it's done. The reputation is broken, and you won't use this Oracle anymore. And this is interesting because with the Bitcoin integration, if you think about it, you could have the Oracle lying to one party, which is not you, and if this party doesn't notice or doesn't want to disclose this information, then the Oracle could keep lying even to other parties. While in this case, you have the Oracle honesty always being stored somewhere, so can be verified by anybody at any time. It means that even if we verify once to a party which doesn't realize what happened, still another party can independently verify that and disclose the information to everybody that can verify in this way that the Oracle is not being honest. So we are working now on the on-chain monitoring of this same thing. So we have not it ready yet, but it's just around the corner. So we were sticking in the first months to verifying the TLS Notary honesty with the TLS Notary project itself, the one we are using now. But the point is that it's not optimized for the verification on chain. When I say verification on chain, I mean that along with the data that we send to the contract and the proof, the contract can verify the proof on chain and avoid to use this data if the proof is not verified. So this means that even if the Oracle is lying once, the data will not be used. So it will be useless. So the point is that with TLS Notary, it's very hard to verify on chain. You will need some blocks because it will be really tens of millions of gas. So very expensive, very slow, not atomic with one transaction, etc. So since last month, we decided to change approach and to say, look, it doesn't make sense to provide an on-chain proof verification in this way because nobody will be using it if it's that expensive. So what we are doing now is forking TLS Notary to provide different type of signatures that are easily and in a cheap way verifiable on chain, so that you will end up spending just some 10 of thousands of gas, which is nothing. Okay? So this is coming in a matter of weeks. We are still testing it. So other things that we are adding are new data sources, like Amazon Mechanical Turk, which is a very interesting one. A public HTTP API, so we already have a private one. If somebody of you is interested in using that, please get in touch. We already have 2 or 3 startups that are using this. This is useful if you want to connect to the blockchain in a custom way, or if you want just to leverage the TLS Notary proof or other proofs without having us to interface with the blockchain. So it doesn't need even to be a blockchain-specific project for this thing. The on-chain verification, the Intel SGX-based proof, as you said, Encrypted queries are already there, they are not documented. We will document them by next week. So if you want to use an API with some private credentials and you don't want to disclose to the whole network your credentials, for example, then you want probably to use encrypted queries, which means that you encrypt your query off-chain before compiling with our public key, so that you are disclosing the credential but just to us. And then we have the Ethercamp IDE, which is now called Ethereum Studio, I was told some hours ago. Integration. This is the IDE that is being used by many major corporations, let's say, that started to do the experimentation, things like that, and even by Andre in his workshop. So this is definitely one of the standard tool that is being used to write code with Ethereum, and we are providing a plugin so that it's very easy and you don't even need to deploy your contract on the actual blockchain. You can just use the emulation of the Ethereum JS, and within the IDE you get all the responses back as on the main chain. So Oraclize is interfaced with the main chain, with the Morten testnet and the consensus testnet, other than custom ways with integration like this one or that one. So this is the idea I was talking about. As you see, you have all the monitoring stuff, testing queries, things like that. So I will show a couple of use cases that we made. So essentially, it's still very, very early. We all know that. And people are having an hard time to understand this technology, the implications. They mostly don't have the right mindset, so they want to use the blockchain just because they don't understand much about databases and things like that. So we started doing some use cases just to show, to give some ideas and to help people understand how to leverage this technology with our Oraclize data providing solution. So this was the winning project at the London FinTech Week Hackathon in September. And it's essentially a peer-to-peer decentralized insurance for flight delays. And essentially, I keep having insurance companies getting to me to know more about this. I will say it again, even here. No, I don't see any way you could have a role in this, but there could be one. I didn't find any yet. And even them are having a hard time to understand what they can provide as a company to a solution like this.
You mean they cannot find a role in this?
Yes.
To find a role.
They cannot understand how they can get their slice out of a system like this, which is decentralized and which works in a completely different way from a flight delay insurance like the one they are providing. So this is a niche. So it's a very specific product. It's not what they are doing. It's a very small piece of what they are doing. This is more like a bet in practice, because there is no verification, for example, of how much you actually lost because of your flight, if you had to attend a conference or things like that, or the payout, the compensation is fixed and is defined on how much you pay. And there is a complex algorithm I can explain to you later if you're interested. But the point is that there is no even verification of the fact that you actually had a ticket for this flight. Okay?
I mean,
so,
not yet, right?
Yeah, but there doesn't need to be. I mean, some of the insurance products are actually more similar to bets, if you think about it. And this just covers some of this. Okay. So this is another example. We have not released it yet. We are testing it on the testnet. This will be released soon. So this is a Stack Exchange bounty contract. So here the data source is 1. It means that we are fully trusting Stack Exchange. And you know that Ethereum has its pretty active lately Stack Exchange community. and that there are questions being asked, and there is not much incentive to give an answer. So this is one way to give an incentive to this, and essentially this is just a way to link to a smart contract a stock exchange question. Can be of Ethereum or even of another section of stock exchange, doesn't matter. So we made the example and we made this for Ethereum because we know that there is a lot of interest and it's obvious this approach. And so here you link the question to the smart contract, and the smart contract does verify if there was an accepted answer. So the acceptance of answers is defined by Stack Exchange. The logic is there, we don't care, and this is not the point of the smart contract. The point of the smart contract is to say anybody, doesn't need to be the one asking the question, can put some money on the valuable information which is the answer they are looking for. And obviously this is an incentive. So anybody can sponsor this question, and as soon as the question will be there, the one giving back the correct answer, correct for Stack Exchange, for the one who asked the question, or for moderators, or for anything, will get the money that are put in this smart contract escrow. So you see that here one question could be, hey, but how does the contract know what is the Ethereum address of the one who gave the answer back? And our solution, which is just one of the possible ones, is to say, okay, let's say that the location field in the profile info needs to be an Ethereum address for the profile who gave the answer. If this is not the case, then the one who get this money can claim the money at a later time. And this is the last one. This is already released and working. So essentially, this is a YouTube escrow contract. So you can link the smart contract to an Ethereum, a YouTube video, and you can say, okay, anybody can sponsor this video, for example, because I talked about them in my video, so it's advertisement and things like that, or anybody, even if it's a fan of the YouTuber or things like that, it can sponsor the video, and even if, just if the threshold that I set will be reached at a given time. For example, let's say that if 1 week after the publishing of the video will reach at least 2,000 views, then the funds will be released in full to the YouTuber. In the other case, I will get, as a sponsor, each sponsor, I will get 25% back. So this means that as a sponsor, you are paying the full amount just if the video will be successful, which you don't know once you're paying. So it's something that is verified at a later time. And the YouTuber cannot get this money before the date is actually reached. So you are 100% sure that you will get back the a small refund if the video is not as successful as expected. Unless YouTube is down. Okay. So these three were all examples of concrete use cases. Most of them are for the community side, while Oraclize is both providing this as a service to companies and to the community. But I think that these three examples can be a good starting point to formulate, to think about new ideas that can leverage pretty much the same logic. So you can find more information at our website. The documentation is not that good, but we will improve it soon. And it's at docs.oraclize.it. It's pretty technical. We have an IDE at dev.oraclize.it, but I wouldn't suggest you to use that. Use the Ethereum Studio 1 instead, which is our plugin integration, which will be released by next week or the one after. It's already ready. If somebody of you wants to see the plugin, just ask me afterwards. And this is our Twitter account and code samples here. So if you're a developer, go here and everything will be much more clear. And that's all. Thank you.
We have some minutes for Q&A.
Do you have a business model?
Sure. Other than consultancy, and as you know, usually when they say that when startups do consultancy, it means that it's near the end of the business. It's about to close, to go bankrupt. But other than this, we are providing APIs on a pay-per-call base, which means that the pricing is set in dollars for each query. And we decided to keep the price low, very low, even if we are the only one with a service like this at the moment. Because the point is that we want to start offering other services around, and we think that this thing will be successful even just if really we receive really a lot of calls. It's not about receiving handling 100 calls per day. It's about thousands. So yes, for example, we have different pricing for queries with proof or without proof, because preparing the TLS notary proof comes at a cost for us, because it's much slower. It needs an infrastructure, so more servers which are kept up on our side, and it's even sending more data, so it's very different, and this is the reason why the price is different. And even when you ask for specific data sources, the price can vary. For example, if you want to use Wolfram Alpha, we have a business contract with them. So you don't have to subscribe to Wolfram Alpha, but we have to pay for it. So the price obviously needs to be higher because it needs to cover our cost.
And the part of Amazon in the TLS validation, that's built into TLS Notary.
Yeah, it's I say TLS Notary, but in practice it's pitch signer, which is a specific use of TLS Notary. But yes, can be replaced. So
yeah, that was would be my actual question. Like, could I, if I don't want to use Amazon to play that part, might there be a way in the future for me to maybe to define a different server or something like that?
In theory, it's possible. In practice, so far, Amazon is the only provider which provides all the APIs needed to verify things that need to be verified. So essentially, there is one piece of the process which is executing the notarization itself. Mm-hmm. So this is called the notary server, and everything is good if the notary server is executing the exact correct code, which is open source. But how do you ensure that the notary server is not lying and is not altered? So in order to do that, you have to be this server to be deployed in a way you can verify it wasn't altered. And Amazon does provide some APIs that can let you check exactly that. Yeah. So you can check, for example, that the loaded kernel is the one you expect, and that the loaded image is exactly that one, and you know that this image is completely locked, so you cannot access it from the outside. And in this way, you are 100% sure, if you trust Amazon, that the code that is running is the right one.
So I find it interesting that the whole Ethereum community as a whole has spent like $4.5 million send it to Augur in order to implement what is a shelling point oracle,
yes,
which is the different design,
yes,
compared to your design.
Yes.
Do you think the shelling point oracle offers something over your solution, or do you think that this investment is going to waste?
It's very different because I think that the use of these two different solutions is way different. So one, this case solves in a good way, I think, the need of immediate data. So if you need some data which is defined and mostly is referred to a fact that already happened. While a prediction market is something very different, and which is defining any fact, and that can even be a fact in the future. right?
My question is a bit different. See, like the prediction market itself, like the reason you need rep, the currency rep, is only because the rep holders can act as independent oracles.
Right.
Right?
Right.
So if you can solve the oracle problem differently and better than them, then there is no use for the rep currency itself.
Right. In fact, Group Gnosis, which is the other prediction market, does use a different model. So they don't have rep holders, but they are relying on an oracle to verify the fact once the event is settled. So at the moment, they are acting as oracles, as Group Gnosis. But it's a few months that we are studying an integration, and we have already some code running to use Oraclize as an oracle to settle with Group Gnosis. So it's just a different approach. I don't think there is one which is better, because even with rep holders, I'm not 100% sure this is more effective than this one. So I think there are really a lot of variables or things that needs to be taken into account. It's just a different approach. I'm not sure there is one better one. So one is the Ogre one, and the other one is Group Gnosis one. It's good to have both. So we will see in practice how the things work with some concrete examples.
What kind of data can you get your hands on? I mean, there's gazillions of data, like financial data, sports results.
If it's legal, it's even better.
But does that mean you have like an API to Bloomberg, or where do you get it? And do you store it yourself? Or?
The examples that I showed before were public APIs. It can be private APIs if you encrypt your query, please, because we don't want to disclose to your network your credentials. For Bloomberg, for example, you can't really access it from the public. You need a terminal. So what if you have a terminal and you want to push this data in? This is not on the internet, right?
So I have to define where to get the data.
You have to define the data source. And if this is Wolfram and it's this is Bloomberg and this is in your local network via your Bloomberg terminal, you can still do that because we provide tools to do that. So you can even rent a black box, which is part of our engine, and keep it in-house. It doesn't make any difference because the proofs are still the same. Simply, you don't want to give us access to your local network. This is fine, and you can still use the same technology.
Does Oraclize provide a non-breaking query? Like, for example, let's say I'm querying Wolfram Alpha for something. Maybe I'm querying it for the stock Apple stock price.
Yep.
Now, if they change the API on their end, like it's one particular format today, their system upgrades, and now you have to send your query in a different format, then my smart contract that depends on that query will not know that Wolfram Alpha system has been upgraded.
Correct.
So will Oraclize make the translation for me?
It cannot do that, and we don't want to do that. So for Wolfram Alpha, it's very unlikely because the query is in a human readable form. And from my experience so far with Wolfram Alpha, I can say that usually they don't drop the support for queries that are already working, but they usually support new types of queries, right? So they can understand more, not less. But of course, it can even be that the YouTube one or any other API or Bitstamp does change the APIs. This usually happens in quite long time. So usually there is deprecation and it takes some time. And this is why with Oraclize-based contracts which are relying on APIs, I think that you are pretty sure of the result you will get back in the short term. So for example, in the use cases of YouTube or Stack Exchange, this is good enough. You don't care because it's very unlikely that you are using an API which is going to be deprecated in 5 days. Okay, but still you can get around the issue by not asking a single data source. So this is your logic. This is very complex. There is no solution. I don't see a solution. And I think that this is something that is better to be handled on the calling smart contract side. So this is a problem which is more about How do we trust centralized data in decentralized networks? What if the data source disappears? What if they change something, right? So this is very difficult, complex, and I think that the only solution is to lower the risk by relying on more data and giving for granted that some data sources could disappear or give back a wrong result.
So I think we have time for one more question. Nope. Okay, cool. And thank you very much, Thomas.